Hello and welcome. In this video we're going to be looking at this Cambridge paper. It's October-November 2019. It's a paper 1, pure mathematics, and we're just going to focus on the first question for now, which reads, find the term independent of x in the expansion of 2x plus 1 over 4x squared to the 6. Now obviously for us to solve this problem we need to consider, because it's a power to the power of 6, which is a large expansion, we can actually use the binomial theorem because all the conditions are met there. So what we need to do now is to show you how the binomial theorem works in terms of that question. So 6 choose 0, that's the first thing. So and then 2x, and then on this one you're going to have 6 minus 0 and then 1 over 4x squared to the power of 0. Now that's the first term. That's how you do the first expansion. It's 6 to 0 referring to this 6. Note that here on here the powers, the number will be increasing up until it gets to 6. Here it will be decreasing, so here is decreasing, and here it will be increasing. This is an increase as well. So that will go on throughout all the terms until this is 6 choose 6. That's basically how the binomial theorem works. So the next term will be 6 choose 1. And then we go 2x, which is our first term. So this is a, let's just call this is more like a plus b, right? And then this, for the first term, we're saying the powers are decreasing. So it will be decreasing by 1. So 6 minus 1, that's the first one. And then the next one will be 1 over 4x squared to the power of 1, because it's increasing. So see here it was 0, it's now 1, and here it was 0, it's now 1, and here it was 6 minus 0. To show that it's decreasing, it will be 6 minus 1. Right, I'm just going to do all the terms, because in this one I'm just trying to show you how you can use the binomial theorem in general, and then we'll zoom in to the one that's required by the question, which is the term independent of x. So the next term will be 6 choose 2, and then you go 2x to the power of 6 minus 2, and then 1 over 4x squared to the power of 2, plus 6 choose 3, and then 2x to the power of 6 minus 3, 1 over 4x squared to the power of 3, plus 6 choose 4, and then you do 2x to the power of 6 minus 4, 1 over 4x squared to the power 4, and then plus 6 choose 5, and then you do 2x to the power 6 minus 5 multiplied by 1 over 4x squared to the power 5. And then after that you do 6 choose 6, which is the last one, 2x to the power 6 minus 6, and then 1 over 4x squared to the power of 6. Okay, so that's how it works there. Now the next step after this is for us to consider which term is independent of x. Now we're looking at this, the 6 choose 1, 6 choose 0, all these are calculator functions. We can input that in the calculator and calculate the value. But the key thing is to look at the powers of x. So you're considering which one, which term will you end up without an x. So you consider this one, this will be 6 to the power, 2 to the 6. If we consider the first term, 6 choose 0, if we go on our calculator, that's 6 choose 0, that will give us 1. So basically this one will be 1 times 2 to the power of 6, x to the power of 6 times any number raised to the power of 0 is 1. So obviously the first term, which is this one here, will have an x. We want the one without an x. So you keep on doing that with trial and error until you get to the 1. But if you consider this one, for instance, if you consider this term, it's easy to see if you have done a couple of these problems that if you raise x to the power of 4 in this case, so if we say 6 choose 2, that will give us 15 on the calculator, and that's going to be times 2 to the power of 4 multiplied by x to the power of 4. And then if you are to raise this x squared to the power of 2, that's going to be 1 over 4 to the power of 2, x to the power of 2 squared, that's x to the power of 4 there. So this, then you will see that in the end this x to the 4 and x to the 4 will cancel out, so you end up with 15 times 2 to the 4, that's 32 times 1 over 4 to the 2. Alright? 2 to the 4, that's 16, sorry, this is 16. This is 16. So then 4 to the 2, that's 16, so this one and this one will cancel out, so your final answer will be just 15 on that problem. So that's how it's working there. So we've come to the end of this video. Always remember to email me if you have any problem, oscardiura@gmail.com.